In no way do we live in a static world. The Earth and the celestial bodies around it are in a constant state of movement and change. Luckily, we live in a time when that change is relatively predictable and not too dramatic. However, this has only been the case intermittently throughout geologic time. There have been many instances in our species' history where fluctuations in climate or other natural forces were not in our favor. Natural disasters come in many forms. Instantaneous lightning strikes can burn down acres of dry forest within days. Tornadoes can rip through neighborhoods, leaving nothing but masonry foundations and chimneys in place. Hurricanes can leave coastal communities with nothing but debt and insurance claims. In the United States alone, natural disasters kill more than 300 people and cost an average of $60 billion yearly. While many people argue that these sorts of events may be increasing in strength and frequency, which they very well could be, they are by no means new. These more recent events are minuscule when compared to some of history's most devastating affairs. Mega disasters of intimidating scale haunt us in the form of archetypal myths that cross all cultural borders. The Sumerian epic of Gilgamesh, Plato's Atlantis, and the biblical story of Noah's Ark all hold witness to our susceptibility to Mother Nature's whim. The Japanese myth of Namazu and the Native American story of Mount Mazama teach us to be wary of the ground beneath our feet, which is capable of volcanic eruptions and earthquakes. These are not solely scenes from the fantastical human imagination, but reflections of real events etched into the very bedrock of our history. Catastrophes so immense that they reshaped landscapes, wiped out thriving societies, and challenged the very survival of our ancestors. Yet, in the face of these overwhelming forces, humanity endured, adapted, and rose again. This video is not intended to instill fear in you, the viewer. Rather, the opposite. The intent here is to show how adaptable the human species is. These ancient catastrophes teach us about our innate ability to withstand the challenges of living in an inherently unpredictable world. From the mysterious disappearance of the Clovis people during the Younger Dryas to the apocalyptic eruption that obliterated the Minoan settlement of Akrotiri, these events serve as stark reminders of nature's power to destroy. But they also highlight the incredible resilience of the human spirit. As we dig into the ruins of these lost worlds, we'll find evidence of this resiliency in the archaeological record. As we unravel the stories of destruction and renewal, showing that time and again humanity has emerged from the ashes stronger and more determined than ever, I want you to think about whether or not we still have that flexible survivability, or if we've become too rigid to recover from a truly mega disaster. We can start by visiting Lake Toba, located in Sumatra, Indonesia. Lake Toba is 62 miles long, 19 miles wide, and reaches a depth of about 1,600 feet, making it the largest lake in the country. Historically, it has been home to the Batak people, who've occupied the area for millennia. The exact date of their arrival is unknown, but since settling around the lake, they have sustained themselves with a combination of agriculture and hunting. Their settlements are known for their distinct and beautiful architecture. While these people may have been aware of the volcanic feature on which they developed their settlements through oral traditions or myths, they were likely unaware of the events that occurred 74,000 years ago. Lake Toba is not your average lake. It is the byproduct of the largest volcanic eruption in at least the past 2.5 million years, sometimes referred to as the Toba supervolcanic eruption. This event ejected vast quantities of smoke and magma into the atmosphere around 74,000 years ago. After expelling its underground magma reservoir, it formed what's known as a caldera, or a crater-like depression in the Earth's crust. This depression is now the cauldron that holds Lake Toba's 244 cubic kilometers of water. To truly understand the scale of this eruption, we can compare it to other known volcanic events that have occurred in more recent years. The Volcanic Explosivity Index, or VEI for short, is a metric used to measure the magnitude of an eruption. It is based on the volume of material emitted from the volcano, as well as the height of its ash cloud. The values range from 0 to 8, with 8 being the most powerful. In this graph, we can see that past volcanoes whose eruptions we deem significant, like Mount St. Helens and the Yellowstone caldera, fall between 5 and 7, with volumes of 1 and 1,000 cubic kilometers of material expelled, respectively. Toba surpassed these and reached a VEI of 8, with an estimated 2,800 cubic kilometers of dense rock material thrust into the atmosphere. Moreover, some of its emissions reached a height of 32 kilometers. For perspective, this is about 4 times the height of the typical commercial airlines we see in the sky. Given our relatively peaceful modern climate, it's hard for us to grasp the scale of such an immense explosion. However, the humans living during this period would have witnessed it firsthand. Those in close proximity would have felt the ground rattle and pulse. They would have heard deafening booms and seen relentless streams of smoke entering the sky. Even those living on different continents would have observed the effects of Toba. It covered an area of 40 million square kilometers in more than 5 millimeters of ash, including regions all over Southeast Asia, the Indian subcontinent, and the Middle East. It's not unreasonable to suggest that such an explosion would have devastated anything in its path, wiping out every human who witnessed it. This is what anthropologist Stanley Ambrose proposed in 1998. Ambrose argued that the Toba eruption, specifically its massive ash cloud, would have dramatically cooled the planet, plunging it into a 6-year-long volcanic winter, followed by 1,000 years of extremely cold and dry climate. Frigid temperatures and intensive glaciation would have triggered food scarcity and famine. He goes on to suggest that this resulted in a population bottleneck, where the human population diminished to around just 10,000 people globally. Building off of this idea is its implications for human evolution. Accordingly, the bottleneck restrained the human population to only the survivors in tropical Africa, who would have then migrated outward and replaced desolated populations of Homo sapiens and other hominins. He argued that this repopulation could help explain the shared genetic roots of all humans, which point back to Africa. So, what does the archaeological record say about this catastrophic event? Do we see evidence of populations who were wiped from the planet, or do we see evidence of humans overcoming such a severe natural disaster? If we're going to test the hypothesis that the eruption did cause a near extinction event, we could search for evidence of human occupations, whether that be full campsites or mere stone tool technologies that suddenly ceased to exist after that event. Archaeologically, this would mean we fail to see such evidence above layers of soil associated with the event, like an ash layer, for example. We can begin farther away and work our way closer to the site of Toba itself to give ourselves a good sample of the archaeological record at hand. In China, for example, archaeologists have observed broad cultural continuity throughout the Pleistocene epoch, between 100,000 and 40,000 years ago. By this, they mean that there was no evolutionary gap or interruption for East Asian humans during this time period. They go on to specify that raw material procurement strategies, stone tool manufacturing technology, lithic typology, artifact morphology, assemblage composition, and trends in regional cultural traditions occurred in one continuous line, indicating that Pleistocene hominids survived and evolved continuously in the region. If humans living in China were affected by the Toba eruption to the point of a population collapse, we would see an abrupt end to their cultural remains 74,000 years ago and the introduction of distinct cultural patterns thereafter. But that is not the case. As stated earlier, India was one of the geographic regions heavily affected by the Toba eruption. Here we have good evidence of volcanic ash, also known as tuff, within the soil stratigraphy. At a site called Jwalapuram, Locality 3, in the Jurera River Valley of southern India, archaeologists tested our very hypothesis. They observed stone tool assemblages found in layers of soil above and below the Toba ash layer. They found that the technology and tool types in both deposits exhibited high degrees of similarity. They consisted of unidirectional cores with flake scars made from limestone, quartzite, and chert. Excess flakes that were reworked into scrapers and blades were also present in both deposits. The researchers conclude with the following statement: "We provide here firm chronological evidence that hominins were present in the Gerera River Valley immediately before and after the Toba eruption. Analyses of the archaeological industries recovered from the site indicate a strong element of technological continuity between the pre- and post-Toba assemblages. One might say that this is not surprising considering the distance between Indonesia and India. Surely it would have immediately wiped out the humans living on the Indonesian island, right? Well, let's not jump to conclusions. The Lida Ajar Pleistocene cave in Sumatra holds an assemblage of anatomical remains attributable to Homo sapiens, including teeth. Using a multitude of dating techniques to pinpoint a chronology of the soil that encompasses those teeth, researchers have dated them to between 73 and 63,000 years ago. This means that anatomically modern humans were living in Sumatra directly after the eruption. One last line of evidence supports the argument that humans are truly resilient when it comes to natural disasters. However, this time we'll recognize the toughness of our smaller cousins, Homo floresiensis. Often called the Hobbit due to its small stature, Homo floresiensis lived on the Indonesian island of Flores. Despite its small brain, it created its own tools on par with those of other human species at the time. Conservative estimates placed the Hobbit on the island of Flores between 100,000 and 60,000 years ago. More liberal estimates argue that they could have persisted on the island as recently as 12,000 years ago. Whether the most recent date is 60 or 12,000 years ago, the evidence suggests that not only did Homo sapiens survive the Toba eruption, but our hominin relatives did as well. So here we have an example of our species and others persisting through one of the most dramatic natural disasters of the past 2 million years. If we fast forward to more recent history, we can see an example of a similar event at a much smaller scale. In this instance, though, we used a different adaptive strategy: abandonment. Like the Batak of Indonesia, the Minoans of the ancient Mediterranean constructed a settlement on a similar caldera. The island of Thera, now known as Santorini, was likely first inhabited around 4500 BC by some distant late Neolithic culture. It wasn't until the Bronze Age, roughly 2000 BC, that the Minoans developed it into a prosperous urban center known as Akrotiri. While the epicenter of Minoan civilization was on the island of Crete, Akrotiri would have been a bustling satellite city, positioned to capitalize on fishing, farming, and trading opportunities. Unlike the Batak people, the Minoans of Akrotiri experienced the volcanic eruption of Thera. The VEI value of this eruption was either a 6 or 7. Despite it not reaching the severity of the Toba eruption, it did not fail to mark its impact with widespread ash and destruction. Archaeological excavations have exposed this destruction, showing the collapse of a once flourishing settlement. Of notable intrigue is the preponderance of ash and pumice ejected from the volcano and what has been found within it. Pumice is a glassy volcanic rock created when lava, with a high content of water and gases, is rapidly discharged from a volcano. Glass bubbles pop and create a Swiss cheese-like texture. As a result, the material loses its density and becomes very light as it hardens. Deposits of ash and pumice entombed the island, reaching depths of up to 23 feet at certain points. Within those deposits, we find 3 essential bits of information that help us tell the story of this disaster. First are 2 olive trees. What role do they play? Well, they're the reason we can accurately date the explosion. Both trees were radiocarbon dated, and they concur that the event occurred around 1613 BC. Second, we see evidence of how prosperous this society was. Everyone knows how the eruption of Mount Vesuvius turned Pompeii into a time capsule. The eruption of Thera had a similar effect on the city of Akrotiri. Buried under the ash and pumice are the remnants of the Minoan art and architecture of the time. Much of it is very well preserved. Some great examples of the art that these people were creating and exhibiting are the many frescoes that archaeological excavations have uncovered. These are colorful wall paintings, often using white, yellow, red, brown, blue, and black pigments. They showcase the sophisticated artistic tradition that reveals a deep connection to nature, a love of beauty, and an advanced skill set, indicating that high art played a central role in Minoan life. The third finding, and arguably the most interesting, is not what has been discovered through archaeological excavations. It's what has not been found. Despite all of the structures, pathways, and artifacts present at this site, there's not a single instance of human remains. In other words, we have no evidence of human loss related to a volcanic eruption within this very city. How could this be possible? We are an extremely smart and flexible species that can observe patterns in the world around us and can respond adaptively. Accordingly, it is believed that the Minoans living in Akrotiri caught wind of what was about to go down. Clear indications of premonitory activity have been found in the excavations at Akrotiri. Broken steps, collapsed walls, houses reduced to ruins, and heaps of debris gathered by the inhabitants have been found beneath the earliest deposits of the Minoan eruption. The inhabitants were certainly aware of the impending eruption, for they had time to remove food and valuables from the ruins. In one place, for example, they removed a set of 3 beds from the ruins, and had placed them one atop the other with their posts upright. The eruption of Thera was not an instantaneous event. It came through multiple phases, some more destructive than others. At its earliest stages, prior to the release of any actual material, the Minoans likely witnessed the rattling of the ground and the cracking of the walls framing their homes. Taking note of this, the inhabitants of Thera abandoned ship. We don't definitively know where they evacuated, but the lack of human remains suggests that these people were warned and took heed of it. We hear these discussions and debates about fight or flight for a reason. It's an interesting concept in the worlds of biology and behavior. Either strategy can be adaptive depending on the context. In the context of volcanic eruptions, flight is probably your best bet. The story of Akrotiri, and by extension the Minoans, is a testament to human resilience in the face of overwhelming natural forces. Despite the impending doom of the Thera eruption, the people of Akrotiri likely recognized the warning signs and evacuated, preserving their lives even as their affluent city was buried in volcanic ash. While their physical settlement was lost, their culture and influence endured. The Minoans adapted, continuing their trade and thriving years even after the disaster. In our final case study of human responses to natural catastrophes, we will come to the most controversial of the 3, and probably the one most of you clicked on this video for, the Younger Dryas. For these reasons, we will go into a little more depth on this topic. As the last ice age was coming to an end, the world was on a brink of a new era. Early human societies were beginning to thrive, and the climate was warming, setting the stage for the birth of agriculture and permanent societies. But then, abruptly, the planet plunged into a deep freeze, the Younger Dryas. For over 1,000 years, this sudden cold snap brought dramatic changes to the environment, causing widespread extinctions and challenging the survival of early human populations. While the exact cause of this event remains debated, one controversial theory suggests that a comet or asteroid impact triggered this sudden climatic reversal. Regardless of the cause, the Younger Dryas was a defining moment in human history, pushing our ancestors to adapt to a rapidly changing and unforgiving world. It's a story of survival and ingenuity, qualities that would shape the future of human civilization. So what exactly was the Younger Dryas, and what caused it? Its name comes from the Dryas octopetala flower. This plant is considered an indicator species because its presence reveals the qualitative status of the environment in which it's found. Accordingly, octopetala is a cold-adapted flower that thrives in glacial conditions and generally appears in mountainous areas. We can then infer that if we see evidence of this plant in the past, then the climate was rather cold at the time. Paleobotanists discovered that this plant was present all over the northern hemisphere around 12,000 years ago, at a time when the Earth was supposedly warming after the last ice age. Concurring with this botanical indication of cold weather, Greenland ice cores have shown that within that warming period there was an abrupt climate event 12,900 years ago that caused global temperatures to rapidly plummet back to their near glacial conditions. This cold plunge lasted roughly 1,300 years, ending around 11,550 years ago. When referring to the Younger Dryas, this is the time period being discussed, named after that resilient, cold-adapted flower. Again, what caused this cooling is not known for sure. One controversial hypothesis has taken the internet by storm. Popularized by figures like Graham Hancock and Randall Carlson, the Younger Dryas Impact Hypothesis posits that an extraterrestrial impact triggered the onset of this cold plunge 12,900 years ago. Its proponents argue that such an impact caused by a fractured comet that burst into pieces upon entering the Earth's atmosphere is responsible for the Younger Dryas climate shift, the extinction of numerous megafauna, and a serious decline in the human population. The impact primarily affected North America, but other continents felt repercussions as well. The evidence they present is not unequivocal, and most mainstream scientists reject their interpretations. That being said, extraterrestrial material has collided with our planet in the past, sometimes resulting in mass extinctions. So, the impact hypothesis should not be completely dismissed. Its evidence comes in two main forms: black mat sediment layers and geochemical impact markers. The notorious black mats refer to a collection of soil layers stratigraphically defined by their dark coloration and are found across North America and elsewhere. They are clear anomalies in the stratigraphy, considering that natural subsoils are typically lighter in shade and align more with hues in the range of red and or yellow. Their black and dark gray appearance is largely due to the greater degree of organic material than the strata above or below them. A study published in 2008 investigated 97 geoarchaeological sites within North America that spanned the transition from the Pleistocene to the Holocene, aka the end of the last glaciation, in search of these black mats. The study yielded the conclusion that approximately 2/3 of these sites have a black organic rich layer, or black mat, in the form of these various paleosols or algal mats, with radiocarbon ages suggesting they are stratigraphic manifestations of the Younger Dryas cooling episode. Of the geochemical impact markers used to defend the impact hypothesis, 3 of the most common include platinum group metals, magnetic microspherules, and nanodiamonds. Platinum group metals are rare on Earth, but are abundant in asteroids and comets, suggesting that their presence in the relatively shallow depths of geoarchaeological excavations indicates an impact. At the Wonder Crater archaeological site in South Africa, researchers have discovered peat deposits with both declines in temperature associated with the Younger Dryas, as well as a significant spike in platinum group metals around 12,800 years ago. The researchers note how this is the first African example of this phenomenon, which is present in more than 25 other sites around the globe. Magnetic microspherules are tiny, rounded particles composed of iron, silica, nickel, and other metals. They are formed under extremely high temperatures and pressures, conditions typically created by volcanic eruptions or high-impact cosmic events. Proponents of the Younger Dryas Impact Hypothesis claim that microspherules that have been recovered from Younger Dryas boundary sediments look to be of extraterrestrial origin when analyzed by X-ray fluorescence and compared with known cosmic and volcanic microspherules. Diamonds are also created under extreme pressure and high temperatures, but are rather abundant on the Earth's surface. Diamonds at the nanometer scale are much more rare, however. How nanodiamonds form is still debated, with little consensus. Impact hypothesis supporters believe that they can be the byproduct of cosmic collisions, and their abundance at multiple Younger Dryas boundary locations across North America points to said collision. Being such a controversial theory, there are counterarguments to each of these claims. For example, one study suggests that the radiocarbon dates between black mat layers show too much variability to be considered one synchronous impact event. Nanodiamond spikes have been found more recently, dating to 3,000 years ago, and we have no evidence of an impact at that time. More recent tests looking for microspherules at or around the Younger Dryas boundary have failed to reproduce results of previous studies where they have been discovered. Proponents on each side of the impact hypothesis debate are often skeptical of the other's evidence and motives. A lack of open communication means that the cause of the Younger Dryas may remain a mystery for a long time. Nevertheless, the common ground we all agree on is that a dramatic shift in the climate occurred at this time. Simultaneously, we see extreme population shifts in megafauna and humans at the time. Up until 13,000 years ago, North America was home to a wide variety of large-bodied animals. These include mammoths, saber-toothed cats, North American camels, and more. Many of these were large, more exaggerated forms of modern animals, such as the giant sloth, armadillo, and dire wolf. At one point, this continent rivaled Africa in the number of megafauna within its boundaries. Today, the vast majority of these species are extinct. This has historically been attributed to what's known as the overkill hypothesis, which posits that the humans who initially entered North America did so with a set of social and cognitive tools, as well as those made from stone, which helped them achieve the status of super predators. Unbeknownst to the species living in North America, the group hunting skills of humans disrupted the continent's ecology. Accordingly, these big game hunting Clovis people arrived shortly before the Younger Dryas and forced a mass extinction event within only a few hundred or a few thousand years. More recently, people have been reconsidering this idea. One reason is that we now have evidence that people were in America long before the Younger Dryas. I made a video on this, which I'll put a link to in the description, but archaeologists are now acknowledging the presence of people in North America 23,000 years ago and older. If the overkill hypothesis is correct, then why didn't these species go extinct closer to this time period, like they supposedly did with the initial contact between our species around 13 or 14,000 years ago? People also find it too coincidental that this megafaunal extinction coincides with the Younger Dryas period. What are the odds that during one of the most dramatic climate shifts in the Pleistocene, humans were the root cause of this extinction event and not the abrupt environmental destabilizations? Lastly, there's now evidence that we were almost susceptible to the same fate as these other species. When we look at the archaeological record, we see cultural changes in artifacts and land usage which point to significant changes in human behavior associated with the Younger Dryas. It was first noted in 2008 that there is a relationship between Clovis artifacts, the earliest cultural tradition on the continent, and the black mats of the Younger Dryas boundary. Observations of archaeological sites in North America with the presence of both Clovis points and black mat layers show that these stone tools are only found below the Younger Dryas boundary, never above. Additionally, at sites where there exists both Clovis tools and tools of a subsequent cultural technology, they are nearly always separated by culturally sterile sediments. A more recent and in-depth study sought to expand upon this observation. To do so, researchers continued an analysis of paleoindian projectile points and added lithic quarries into the mix. The paleoindians who first inhabited North America were able to identify sources of vital stone material across the landscape. Many quarries that were used by these people have been identified, and the researchers conducting this study tested whether or not there is a decline in quarry usage after the onset of the Younger Dryas. Lastly, they conducted a radiocarbon analysis to infer population sizes during this time. After their study, they came to the conclusion that all three datasets, projectile points, quarries, and radiocarbon data, indicate that a major human population decrease or bottleneck, or alternatively population reorganization, occurred over broad areas of North America at the onset of the Younger Dryas cooling episode 12,900 years ago. In other words, they confirmed that Clovis projectile points ceased to appear, and their quarries show minimal or no use after that boundary layer. This is capped with the radiocarbon data suggesting a major decline in the human population of North America. Importantly, it is not argued that the human population of the continent was totally wiped out. In fact, they show how, in the latter half of the Younger Dryas, a rebound in population or settlement is indicated by increased numbers of projectile points, quarry usage, and trends indicated by the radiocarbon datasets in most areas. What does this mean? It suggests that humans not only survived the disastrous climate shifts of the Younger Dryas, but learned to adapt resiliently. One example of this we see in archaeology is the modification of paleoindian projectile points. While the distinctly Clovis fluted points do disappear after the Younger Dryas, new variants emerge, some of which maintain the fluted technology, like the Folsom points of the mid and southwest. These are different from Clovis points in that they are typically much smaller and their flute channels run the entire length of the tool, from base to tip. Why the change in form? With no megafauna left to hunt, paleoindians were forced to capitalize on smaller game animals like normal-sized deer, rabbits, and bison. The smaller points were likely more effective for catching these smaller, more agile prey. The Younger Dryas marks a period of profound environmental upheaval, one that had significant impacts on human populations and ecosystems alike. Evidence of dramatic climate cooling, megafaunal extinctions, and shifts in human settlement patterns highlights the resiliency and adaptability of early humans in North America. Whether the event was triggered by an extraterrestrial impact or natural climate variability, its consequences forced Paleo-Indian populations to modify their toolkits and reconfigure their hunting strategies and settlement structures, leaving behind a complex archaeological record of change and survival. These settlement patterns, reflected in the archaeological sites of the period, underscore humanity's ability to navigate and adapt to extreme environmental challenges. This theme echoes throughout human history, as we have seen. As we continue to study the Younger Dryas, it offers valuable insights into both the fragility of ecosystems and the enduring resilience of human societies. Between the eruptions at Toba and Thera, the Younger Dryas, and countless other natural disasters, human populations have been on the brink of collapse at various points throughout our history. The archaeological record tells us how we've managed to avoid that and persist through the ages. Fast forward to today, though, and we live in a very different world. We are more reliant on our technology and infrastructure than ever before. It would be a serious issue if a mega disaster of this scale or greater were to occur again and demolish some of that critical infrastructure. It could shut down the power grid, leaving us without our beloved internet, or collapse the supply chain, making food unavailable. So what do you think? Would we be as adaptable and flexible as past humans? Or are we too dependent on our technological infrastructure?